Hello, welcome back. We're talking about this time about graphing the logarithm functions. So it is very similar to what we have done before in graphing the exponential functions. So we define 2 points. Point number one, when with exponential function, we define 0 and 1, and 1 and b. So in this way, we're gonna reverse the x with y and y with x. So the 0 and 1 becomes 1 and 0, and 1 and b becomes b and 1. So in order to understand this idea, we're gonna start about, we have to understand, number one, that exponential function and logarithm functions are inverse of each other. The domain of the exponential function is the range of the logarithm function, and the range of the exponential function is the domain of the logarithm function. In this way, we will understand how it goes in both exponential and logarithm. So based on the graph before, when we have to inverse, we graph the line y equals x and reflect the inverse about that line. So based on that technique, we're going to learn today how to graph the function, and we start by graphing y equals 2 to the x, and I graph from that log 2x. So let me share that first, and we're gonna go with this screen, and then ring. So here in my screen, I graph the function y equals 2 to the x, and I'm going to graph the function. So I need to graph the function is y equals log 2 to the x. So basically, these two functions this is the inverse of the exponential function. So I start by graphing y equals x, and then graph the other function about or reflected of this function y equals 2 to the x. Okay, so let's start by graphing the line y equals x. So this is y equals x. Now, I define some points here. So this point here is 0 and 1. Remember, this is a passing point and the exponential function. The other point is b, 1 and b. So b here, I have that b is 2, because here is 2 and here is 2. Okay? So now I have the two passing points. For the exponential and the log. So I have for exponential, I have 0 and 1. So for the log, that becomes 1 and 0. And for exponential, I have the point 1 and b, which is 2 here. And for the log, that becomes 2 and 1. Okay? So let's define these 2 points. So I have number 1, I have 1 and 0. So I go to 1 and 0. Here's 1. Here's 1. I graph this one. Let's make it in red. Will be different. Okay. And now I'm graphing, or I'm defining the point 2 and 1, because this 2 is b and 1 is the y coordinate in the logarithm function. So 2 and 1. So here is 2 and 1, and I have 0. I have 1 and 0. Okay, so I'm going to graph this simply, but I need to do some other points. So let's say if I have x is 3, x is 3. So for the first function, first function, if x is 3, then I have 2 to the 3, or 2 cubed, which is 8. In the log function, I have to swap them. So I have 8 and 3. Well, let's figure out, this is 3 and 8. There's a point, 3 and 8. And I have to find the point here, 8 and 3. It's 8 and 3. Okay? And I think I need to do that in red. Let's get a point down here. I would say, let's say another point here. So I would say 1/2. So 2 to 1/2. That's the square root of 2. Let's take another number. Let's say another point here. When we have -2, so here is -2. So 2 to -2 is 1/4. So here I have -2, and 1/4. And here it becomes 1/4 and -2. Okay, so where is 1/4 and -2? So 1/4 is here, because this is 1, so it must be here, and -2. Oh, that must be here. So now it gives me the shape, how it goes, so I can go this way, and then graph this down this way. So notice something that, and this is log 2 to the x, y equals log 2 to the x. So notice something. First of all, we are both reflected about y equals x. Now, so let's define 3 things here. Number 1, the domain of the exponential, remember, it's from -infinity to infinity. Let's make here the log. So here is the range. The range of log is -infinity to infinity. Now here's the range of the exponential. If you remember, that was 0 open to infinity. Therefore, the domain of the log is the same, 0 to infinity. So what I mean that the domain becomes the range, and the range becomes the domain, because they are the inverse of each other. The third thing is the asymptote. Asymptote. So remember, for the exponential, as we said before, that y equals 0, that the horizontal asymptote But in the log here, so I have here, let's write horizontal asymptote. I'm gonna make this smaller here. So here is horizontal asymptote, y equals 0. Here for the log, guess what? Look at the log here. So here is a horizontal asymptote for the exponential function. It doesn't touch the y equals 0. But here, look at the log function. It doesn't touch what? Vertical asymptote, which is x equals 0. So these are the difference between in graphing between these two functions. So let's write them down, list them so fast, and as this is in your notes. So number one, as I explained, that the domain of the log function, the domain, I'm talking right now about the log function, is from 0 to infinity. And this is clear here. So if you look at the domain, it doesn't touch the 0, but it goes all the way down to infinity. So it must be positive. So it's greater than 0, but it doesn't go to the negative part. The range, which is a domain of the exponential function, is from negative infinity to infinity, all the real numbers. So if you see here, the range goes from negative infinity up to infinity. So if you look at the function. Okay, the third thing is the asymptote. I have vertical asymptote, which is x equals 0. And the fourth thing is the two things that we're talking about, the behaviors of the function with b. So if b is greater than 1 or a fraction, so I'm going to talk about that here. So if I have b is greater than 1, the function is increasing. Okay, and the way is to graph it is that way. So it's the same way that we graphed before. Okay, and it passes through 2 points. Here must be 1 and 0, and here must be somewhere here is b and 1. Okay, so this is the increasing function, or b is greater than 1. Okay, the other one is b is between the 0 and 1. It's just a fraction, so it's number, case A, 1, in this case 2. So for this one, the function is decreasing. And if we look at the function here, so again, it must go for 1 and 0. But this time, the function goes this way. Oops. The function goes this way. So b is between 0 and 1. So b must be here, and b is, let's say, 1/4 or so. So it must be somewhere here. And this is, let's say, this one. So this is b and 1. So if you see here, b comes first, and then 1. Here is the 1 comes first, and then b, because b is greater than 1. Okay, so let's make this 2 points in red, so you can see the difference between the increasing and the decreasing. Okay, I hope that this is clear. I'm going to give you a couple of examples, and that would be the end of the video. How to graph these functions. So I have example 1. I have to graph y equals log base 5 to x. So first step, define the base. B equals 5. Oh, this is greater than 1, increasing. So we're gonna graph it this way. Okay. All right. So again, we're gonna define the 2 points. The first point must be 1 and 0. The second point is b, which is 5 and 1. Okay, I define the 2 points. So I go and graph the number line here, or the coordinates, I'm sorry. And then I have to define the 2 points, 1 and 0. So let's say this is 1 and 0. Let's make it in red. And the other point is 5 and 1. So this 1, 2, 3, 4, 5. Oh, I didn't. Let's say that. Let's say here's 1. There's 1 and 0. 1, 2, 3, 4, 5, and 1. And now you can graph this function this way. And this function is y equals log 5 to the x. All right, and you can say that it's increasing because of the graph. I hope that this is helpful here. So let's get another example, and that would be the last example. Y equals log 3 of x plus 4. So similar to the last example, base is 3, but here I have a kind of transformation. So this is the domain. If you remember that, when I tell you that when you work in the domain, you use horizontal shifting, but here is plus 4, so I shift this to the left. So I go here, this is shift to the left. Okay, so I have to define the 2 points. I have b equals 3, it's greater than 1, increasing. So the 2 points must be 1 and 0, and 3 and 1. Well, let's graph this. So I have to graph the original function first, which is log 3x, and then I will shift it. Okay, so let's graph that. And I have to define 1 and 0. So 1 and 0. And then 3 and 1. 2, 3, and 1. And then I graph the function. Let's do the green one here. Oops. Okay. So again, the function doesn't touch the x0 or the y-axis. So here is the point. This point is 1 and 0, and this point is 3 and 1. Now I need to shift this 4 points. So I have this is x0, right? So when you shifted 4 points to the left, I'm gonna make a virtual line, which is x is -4. So I'm gonna go 4 points to the left. So I'm gonna make this x is -4. 1, 2, 3, 4. It must be here. I'm gonna make this, let's make this in red. Okay, and this point is -4. So now I'm shifting these 2 points, and the x-axis, the x-coordinate, I have to subtract 4 in both of these. So this point must be 3 minus 4, which is going to be -1 and 1. I'm going to go here and find -1 and 1. So this one, this is -1, -1 and 1. That must be this point. Let's make it red. And this is -1 and 1. The second point is this one, and 1 and 0. So when I subtract 4, that would be -3 and 0. So -3 here and 0, that must be here. Let's grab this. Oops, I want to make it red. And then I'm going to graph it in maybe in another color. Let's say, I don't know. Let's say purple. Okay, and then I go here, and then that goes this way. Okay. So now, let's think about the domain and the range. So here's the domain. I think I need to graph it better. Okay, maybe better this time. So here is, the point is -3 and 0. So here's the domain. Now this is x equals -4. So the domain of this one, the domain of the main one is from 0, because that goes to 0 here, from 0 to infinity. But here I shifted it to the left. So the domain of the transformed function is -4 and 0. And the vertical asymptote here is x, let's say x equals -4. The range is the same. The range is the same from -infinity to infinity. All right. So this is all I wanted to know about this section. And I hope you get the idea here. And thank you so much for working with me today. And I hope you get it. Thank you and have a good one.